from one bending machine to another. So today we are here at LVD and there is a challenge up for us that's called the Dynacell Challenge. So let's walk over to Mr. Matthew Fowles, who will be telling us all about this challenge. So Mr. Matthew, would you like to explain to us about LVD and also tell us about the Dynacell Challenge?
Sure, no problem. Well, first of all, good morning everybody and welcome to the LVD stand at IMTEX 2020.
Thank you so much.
So at IMTEX this year, what we're featuring is the Dynacell. So Dynacell is a fresh take on press brake automation. So typically, when we're talking to customers that have seen press brake automation before, they're thinking four things. They're looking at the machine and they're thinking, okay, it's a press brake with automation. But they're perhaps thinking, maybe the whole unit, the whole actual cell cost is quite expensive. Normally the ratio of cost to the standalone bending machine to the overall cell cost is about 1 to 3. So they're thinking about the cost per part. And typically with automation, that the economics can only really work when you have volume. However, one of the trends that is in manufacturing at the moment is high mix, low volume. But also people need to have an automated solution to enable them to be able to make parts cost effectively. So with a ratio of 1 to 1, which is what the Dynacell has, which is it's only the total cost of the cell is just twice the cost of the standalone bending machine inside the cell. The second thing is that people think that robotized bending takes a long time to program. They're thinking that they have to teach the robot where to follow the part during the bending cycle. With Dynacell, what we've done is we've developed a unique software solution which follows what we call the 10-10 rule. So that's just 10 minutes for programming, which we're going to see in a minute, and just 10 minutes for setup of the tooling and the production of the first part. So that's art to part, so electronic part to finished piece part in just 20 minutes. The third thing that is inside the customer's mind when they're looking at the cell is that they're thinking, particularly if they know a little bit about robotization, they're thinking to enable them to be able to manipulate the different geometries of parts, that they'll have to have a whole different set of grippers that actually holds the part. So LVD have developed and patented a universal gripper, which enables us to hold all the different series of parts that the cell can process without having to change the gripper. So this saves a lot on time, but also on cost, which helps you maintain a low cost per part.
So would you like to walk me to the place and explain this further?
Sure, no problem. So the best thing that we should do now is we will go and take the art part challenge.
Yes.
Okay, as you can see here, well, this is what we are promoting. So we're actually now going to go to the software station and we're actually going to see exactly how easy it is to be able to program a part.
Sir, would you introduce yourself, please?
Sorry, I'm Martin. I'm an application engineer for LVD, so explaining software and machine for customers. Okay.
So remember now, I was speaking to the customer, and they were thinking these things about their conception of what automation on bending is. So we say, let's see exactly how easy it is to program. So what we have here is we have a profile that we're actually going to make with our software. Okay? And what Martin will do, and the best thing to do is to imagine that I am the customer, and Martin will guide me through making the part. Okay? So, over to you, Martin.
So now we're gonna, in our bend software is the Katman B, we call this. We make this profile. So by drawing like this, okay? Then I ask the customer what he likes to have the dimensions of the part. So make sure it's his part and not the part we just picked. So, so I modify these dimensions and function what he said. Ask, for example, we say we're gonna go for the maybe Matt choose,
yeah. So I will choose.
So for example, this one.
So between 12 and 40 millimeters.
Exactly.
Can I have 25, please?
25. Okay, so
and
then B.
Dimension B, can I have 17?
17, okay, and then we have A.
And dimension C?
Is
13, please.
13.
So this is my part.
Yeah, this is your part. See here? So now we're going to adapt the bending length in function of the pre-cut parts we have. Okay, and also this one, you say lock, and now we adapt unfold length and function of the part we have already cut.
So what we've done here is we're trying to show the customer almost like a live part that could be their part. Actually, we're going to give it my name. Okay, so the customer is involved in seeing that it's not a pre-prepared part. What Martin will do now is, because we have to already have cut the blank to be able to process the part, he just adapts the actual overall development of the part to suit the blank that we have. And what he will do next is automatically generate the bending program. Okay?
Now we can say okay. We have a parameters. This is the other part in 3D. And now we can say to the software, please now look for a bend solution. So automatically he will generate the program. See, we have a solution, we have a simulation, we have a tool setup, and we have the NC program to use on the machine. Okay? And this is now in 3D the bend solution. So we can follow how he's gonna bend this part. Like this. For now we're gonna save the part on the database and say, for example, IMTEX.
IMTEX TV.
Pretty cool having a part named after us.
There you go.
Yeah. So now we're going to save it. So we have the bend solution. Now we're going to generate a file where all this information in it, and we can use it in the robot software. Okay. So now we go to the robot software. Here we're going to open the layout from the machine we have here. So this meaning layout, what kind of machine, what kind of robot, and also what kind of input station we have and output stations. So you can perfectly see different, for example, a big box, or just a pallet, or the different input station. Well,
sorry, just to add to what Martin is explaining here, one of the things that's very difficult in manufacturing now is being able to find skilled labor. Yeah. Okay, so not only is it difficult to find skilled sheet metal workers, but it's even more difficult to find someone that knows how to program a robot. So what you're seeing here with Martin, and Martin can continue clicking and actually showing how we're going to generate the robot program, is we literally take the 3D part, we put it inside LVD's Cabman B bending software. We automatically have generated the bending program, and now, very simply, Martin has transferred that data inside the robot software, robot programming software, and it will automatically now generate all the robot program without any interaction. So he literally has to bring the part in,
so now
and it will do it all automatically.
Over this one, say now open. In the meantime, now he's searching for all different gripper positions, we call it, to make this part. So you see now, we have the get, this meaning how he's going to get his part, and he's already calculated the position of the robot. Okay. Same for bending, for example. See how he's presenting the part, and after bending, this is completely calculated how we position the robot. So for now, if we use this information here, this is normally here we're going to create the commands of the robot program, which is normally done manually, working with the robot and teach your robot to do this, which is normally takes a lot of time. So here we just, by pushing apply, here we're going to use this information and make automatically all different commands to make this part happen on the machine. So this is normally for such kind of thing you need 1 hour to teach completely your robot. So here we do it automatically. Okay.
Martin, whilst we continue, Martin will just finish off this, and what he's going to do now is he'll actually complete the robot program, and he's just going to now tell the software where he wants to place the part, the finished part. So one of the reasons why this is such a unique solution is that, as we said before, people can't find skilled labor, but they also can't find a robot programmer, so they want simplicity. Do you remember we were talking about the 3 things that differentiates Dynacell? Yes. If you add all of these together, what it means is we have now a very, very cost-effective solution for being able to bend small to medium-sized parts in varying different batch sizes, where the intelligence and the solution is inside LVD's intelligent programming wizard. So with that, I think Martin is actually finished off.
Now I generated, we call it a job. So this is a zip file we create with all information for the robot. And now we're gonna put the bending program and the robot program together by saying here, associate with robots. So we go use this zip file and say open, and now you see now in our tree structure we have also the robot program in our bending program. So we're gonna save it now here on the stick and say save. So now should be now.
So we will bring the program, and you're gonna make your part.
Yay!
What he's gonna do is he's gonna load the program in.
Okay.
And you're going to make your part, your IMTEX TV part.
IMTEX TV part. So sir, while the part's being made, I would like to ask you, how long have you been visiting IMTEX?
Yeah, we've been exhibiting here at IMTEX since 2008, so quite some time now.
Yes. How far do you think IMTEX has come, so according to what you've seen in terms of quality, in terms of exhibitors and visitors?
It's evolved very well. I've actually visited quite a few of those IMTEXs over the years, and it's good to see how it has also evolved also from a technology standpoint as well. Is that obviously Indian manufacturing culture is also evolving, like all the other cultures around the world, and IMTEX is I think doing an extremely good job of providing the stage to be able to showcase some of the latest technologies that can help the Indian manufacturing base maintain not just their national competitive edge, but also their international competitive edge.
That's a pretty cool view on that, sir. So sir, are we ready?
Yeah, sure.
So we're gonna say start. Okay, the bending program is already now.
So your program is loaded, and now you have to make your part. So Martin will ask you to press the buttons.
Now please push this button. So now we're gonna start the program. So he's referencing the machine, checking the robot, also calibrating the double sheet detection. And now once it is finished, he's gonna start. So now we're gonna speed up to the maximum speed. So now he will get his part, do the peeling, which is automatically done in our software, goes to the double sheet detection, which is okay now, and then he's going to the center table to center perfectly the part, and now he's going to the machine and bend the part. And this is completely, see, this robot is completely done fully automatically. So no manual, manual teaching anymore. So this is done in 10 minutes, completely automatically.
So how do you think your machine faces in terms of the Industry 4.2 idea?
Well, Industry 4.0 is, maybe some of the people watching this know, is Industry 4.0 is actually a technology that enables you to use big data to be able to measure and to use big data to be able to help you manage your processes. So with this particular machine, it uses LVD's Touch B controller, which is fully integrated with a centralized database. And we can actually also work together with our other CAD-MAN software modules, and CAD-MAN actually is LVD's name for all our software modules that enables us to knit all the core processes of sheet metal working together. So laser, punching, bending, and then obviously with CAD-MAN we integrate those processes. So this particular cell is of course Industry 4.0 compatible. We can use that big data to enable you to help manage the process and to improve your efficiency and profitability.
That's pretty cool, sir. So,
I'll do it again.
So sir, now that you have this automatic technology, what do you think is the future for technology in the manufacturing industry, especially in India?
I think it's all about with not just automation, which we are, the way that we approach a lot of things in the company of LVD is we're a very strongly innovation-driven company, but it's not just innovation for innovation's sake. What we do on a daily basis is really challenge conventional thinking. And what we're thinking about is obviously it's about direct cost per part. How can you make manufacturing more efficient? How can you increase our clients' profitability and their ability to add value to their clients? So if you take automation as a whole, one of our strategies is don't over-automate. So remember when we were talking a few minutes ago about the capital cost of the cell?
Yes.
If you over-automated, what you would do is have a higher cost of the cell, which means that your direct cost per part is higher. So the only way that you can make that work economically is by making a larger batch of parts. So with this particular cell here, and also how we think for also cells in the future, is you have to strike that perfect, what we call price-performance balance. So that is basically looking at the application, considering what is the right solution, and then striking the correct balance of the performance of the machine, functionality, versus its cost, which will then give you an optimized cost per part.
That's an interesting take on that, sir. I haven't heard that in quite a bit. So, another question I'd like to ask you is, there was a slowdown in the economy in 2018 and 2019, and did you all get affected by it in any way? And what do you think are your expectations for 2020?
Sure. Well, the nature of our type of industry in capital machine sales and machine tools for manufacturing is it can be a bit cyclical. Luckily, as a manufacturer ourselves, we have huge diversity. So we're involved in 12 main core sheet metal working core markets, and that's really diverse. So that's things like transportation, aerospace, catering equipment, electronic equipment, agriculture, right across the whole spectrum. So a product that could have been made on an LVD will touch your lives in many more ways you could possibly imagine. So that, and the fact that we also have a global market, we're very lucky in the fact that that balance, should there be a slight downturn in any market, we have our counter-cyclical strategy, which is to make sure that we have that diversity. So LVD is an organization. As and when that happens, we are able to cope with that quite well. Considering your question about 2020, you know, that is obviously one of the things that is on people's minds. Again, what we hope as an organization is that if there is a downturn, that isn't so big. One of the things that is important is, as and when that is happening, manufacturing companies also need to consider their competitive edge. So a lot of people will think that the time to invest is when there is lots and lots of work, okay, and they look at basically buying more machines and more software because of capacity. But also, one of the best times to invest is also when you're looking at maintaining your competitive edge, particularly when you have a slightly tighter market and there's more competition. That's when you really need to look at the efficiency of your processes. So what we also see is that as and when those downturns happen, as I say, in our type of industry over the years, it can tend to be a little bit cyclical, is people do tend to also invest. If things do slow down a little bit, they continue to invest because they realize they have to maintain their competitive edge. So it's about making sure that you make that part to the best possible cost you can, because that's maintaining your margin, keeps you competitive against your competition.
So my last question for you today is, what is your wish for IMTEX? What do you think IMTEX can improve upon or can aim for in the future?
I think, like I said a few minutes ago when you asked me the question about how we've seen IMTEX evolve, is that we would like to see that evolution process continue. And I think that the ITMA have obviously got their finger well on the pulse of that. And I think it's important that it reaches the whole extent of manufacturing companies here in India. So not just the larger to medium-sized companies, but all the way through the manufacturing chain. Because technology, the question that you asked earlier, technology with the right balance of price and performance is something that all manufacturers need. They need to understand how that can help them, and that's one of the things that it is our job as manufacturers to do here at IMTEX and at any other trade show around the world, is to help them relate what they see to how it can add value to their business.
Thank you so much, sir, for this interview, and thank you so much for your time. You gave us some excellent investing advice. Yes. I'm pretty sure the audience of IMTEX TV is going to take you up on it.
Fantastic.
Thank you so much. Thank you so much for your time.
Please, here you have the part.
Thank you. So this is the IMTEX TV part given to us by LVD and their Dynacell challenge. This was an interesting look into LVD. Let's see what the other stalls have in store for us. Thank you.